Okay, so what we're looking at here is reducing balance depreciation. So if an item depreciates by the reducing balance depreciation method, then its value decreases by a fixed rate each unit time interval. Generally, what we're going to be looking at is probably each year. This rate is a percentage of that previous value. So it's different to the flat rate, because remember, flat rate was a flat rate over each year. This is percentage of the previous value. So it's sort of analogous to the compound interest stuff, but sort of in reverse, because we're looking for the negative now, and we'll see where the negative part comes in. It's also referred to as diminishing value depreciation. So our recursion relation is what we see here. Vn plus 1 equals R Vn, and where you got a V0 there. Now, what's R? R is this. 1 minus R over 100, and it's the minus here. It's this minus here that gives you that negative part as opposed to like the compound interest stuff, okay? So when we actually do some calculations, so sometimes you will be asked this, so you need to be able to define what that is, but what you also need is this. You need to have that there because that's what you're going to use to make your calculations, okay? Where Vn, remember Vn is a book value after any time t, so that's that Vn here, so that's this bit there. I should actually use a pen thing as opposed to a highlighter because that makes it really hard to see. Oops, there we go. So it's this to that, okay? R is the rate of depreciation, V0 is your cost price, like you bought it for 15 grand or 20 grand or whatever it is, and N is the time since purchase. Now, one of the things you will look at is sometimes if you know the scrap value, like, so it's like saying bought the photocopy for 20 grand and its scrap value is 5 grand. How many years do I, using this depreciation method, how many years do I have to use that photocopier? You can work that out. So basically this one, you're solving for N, okay? You're after N, that's where you'd use a solve functionality, okay? Alternatively, you can use, I don't know why this was doing this, I'll have to fix that up later. Time zero, you can use a formula, here, and I'll show, we'll give you some screen clippings of those later on. You can also use TVM, potentially use TVM solver, okay? Using those particular values where your interest is negative, your V0 is negative, your Vn, so your final value is positive, okay? So what you end up with, this is straight, so what this is trying to highlight, straight line and reducing balance. Straight line, because your depreciation amount each year is the same, it goes in a straight line. And what you'll find if you plotted those over one another, you'll see that effectively this one will be something looking like probably, maybe not quite that bad. But what happens is the reducing balance, so the value of your whatever it is you're looking at will drop quicker at the start with reducing balance, but then that starts to slow down. Now this is probably not the best example, but we'll go through some questions where we look at that and make that comparison and say, you can see where in terms of the value of, say, your car is better using reducing balance as opposed to a straight line, and where straight line's better. Okay, so that's the theory part. All right, so let's have a look at some questions. Got the recurrence relation up the top, and we've got our formula there. So those are important formulas to have, and I actually probably would put those in your summary book. Okay, so generated depreciation schedule using a recurrence relation for the first 5 years. So let's actually, in this one, let's actually work out what the recurrence relation is first. Okay, our recurrence relation here. So we're going to go. We need to find out what, in this case, what So you're looking for what R is. So let's calculate R to start with. Remember, R is equal to 1 minus little r over 100. Now, that was our R, that was our V0. Yeah, so that's all we've got it there. So that's going to be 1 minus 20 over 100. That'll give you, because that's going to be 0.2, so that's going to give you 0.8. So when we write out a, what do we call, recurrence relation, you're going to write it as Vn plus 1 equals 0.8 Vn, comma, V0 equals, and it was 15,000, and we write like that. That's a recurrence relation. Now, that's not what the question was asking, but it's good to just put it out there. Now we've got to do the schedule. So what that means is basically you're using this formula now. So you're saying Vn equals V0 Rn, and we're solving for V0 each time. So when that's V0, that means we've got 15,000 times 1, because that to the 0 is 1. Then we have V1, and if we have V1, we're going 15,000 times 0.8 to the 1, so that's 0.8. And that'll give you 12,000. Then you go V2, 15,000 times 0.8 squared, and that'll give you 9,600. Now, much easier way, get your calculator, use that formula, let it fill down, then you ask to plot, and you'll get this plot here, okay? All right, so we've just done 3. Okay, so that's sort of giving you, haven't that finished at all, but that's our schedule. So we've done our schedule, so we've got our, you'd have another one there. 50 year would be 4915.20. Okay, so if that's all it takes. Is you put that equation in, fill down, you've generated your schedule. You must write the answers in, but you've generated your schedule. What is the future value after 5 years? Well, you've just calculated that here. Okay, so that's 4915.20. Okay, you've already done that, and then you've plotted it, so you've done all each part. So 3, you've done 1, 2, and 3 there. Next worked example: transport business has bought a new bus for 60 grand. V0 R, if that was for flat rate, or R for reduce balance. Okay. All right. Generate this depreciation schedule for both methods for the 5 years. We go 1, 2, 3, 4, 5. That is for reducing balance. This one's for flat rate. Just so you can sort of know. And again, use your calculator. I'm not going to write out all the answers there. It's a waste of time. But you'll see there's some numbers down there. So, okay. So you'll see that after 5 years, the flat rate 1 has gone to 0. Okay. And you'll see that after 5 years, there's still some left over on the on this one here. Okay. So we've got about 10 grand left over. All right. So that there, so 5 would be 10,084.2. That's 0. Okay. Draw graphs. You've drawn a graph. Use your calculator again to do that. After how many years does the reducing balance future value become greater than the flat rate? This is where it's saying where it's got a comparative here. What you see is the blue. So the blue is corresponding to the reducing balance, and you'll notice that it's initially dropped faster than the flat rate, and it stays that way until it gets to the 4th year. And after the 4th year, you've actually got more value left in your car using the reducing balance compared to the flat rate. But if you sell your car within 2 years, go flat rate. If you sell your car in 6 years, or even 5 years, then you'd go for the reducing balance. Okay, that's what that's what that question is telling you. It's saying that after 4 years, the reducing balance method is the best option. Before that, you'd go flat rate. Okay, so there's not much to write on that one, other than let's actually write that. Future values for reducing balance is greater than that of flat rate after 4 years. Keep in mind, the question might ask you which is the better option after 2 years. If that was the case, you'd say flat rate. Okay. Worked example 17. The printing press for worked example 13, that was one of the worked example 13 from memory was this one here. Okay. Was depreciated by the reducing balance method at 20% per annum. What will the future value be and the total depreciation of the press after 5 years if it cost 15 grand new? So V0 R, and this is giving you a time frame of N. Okay, let's calculate our R. First, our R is going to be 1 minus R over 100. So 1 minus 0.2. So that's going to be 0.8. Okay, so we put that into our equation. Equation was Vn equals V0 Rn. So it's going to be V5. So V0 in this case was 15 grand times R was 0.8. Oops. 0.8. And our N is 5. Okay, so V5 is equal to 4915.2. All right, so you've actually calculated that is your future value after 5 years is $4915.2. Okay. Total depreciation. Well, total depreciation. Total. I was going to put total D. That was your V0 minus V5. So 15,000 minus 4915.2 will give you 10,084.8. Okay, so that's your total depreciation. So put total D is 10,084.80. Okay, so that's an example of where you're looking at how much it's going to cost after a certain point and how much it's depreciated. So it started off at 15 grand, and after 5 years, it's only worth just below 5 grand. So you've lost 10 grand in value after 5 years. That's what that's saying there. All right. So in this case, a photocopier was purchased for 8 grand. So that's your V0. That's your R. This is your scrap value. Okay. So that's your VN. How long will it be? That is your N. That is your unknown. You're solving for N in this case. All right. So you could write those out if you wanted to and put like a question mark next to it in, or highlight it like that so you're clear of what you've got. So let's look at that. You've got your R is equal to 1 minus, in this case it's 25 over 100. That's going to be 0.75. All right, so then we put in Vn equals V0 Rn. So V0 in this case was 8 grand times R was 0.75. Our N is what we're after. So in this case, use solve. You'll get an N of 6.59 years. Okay. Now, depreciation is calculated once a year. Okay. So N will equal 7 years. Okay. So N equals 7 years. So photocopier scrap value after 7 years. Okay. Was reached at scrap value. Okay. And that's reducing balance depreciation. Thank you.